Hello everyone, welcome to another Henstitute help video. Since I put this as a quiz question, I wanted to make sure that we all knew how to actually solve this. So this is just a sample one. We've got a particle with a net charge of 5 coulombs, positive 5, is moving with a velocity of 2 meters per second in the x direction and 4 meters per second in the y direction. It has no z component. It encounters a magnetic field of 3 teslas in the y component and 6 teslas in the negative z component. It has no x component. And it wants to know what's the magnetic force acting on this particle. So we know that the magnetic force is QV crossed with B. Okay, so the way we're going to actually find this is we're going to solve this 3 by 3 matrix. We're going to basically find the determinant of it. So what I'm suggesting is here we put Q times the Vx, Q times the Vy, and Q times the Vz. And then down here we'll have Bx, By, Bz. And so we're going to solve that. Now, I actually know those numbers, so let's go ahead and put them in. So we have I, J, K. So the top is always the 3 unit vectors we have in the x, y, z direction. So Q times Vx. Okay, so this is Vx and this is Q. So I'm going to take 5 times 2. So I'm just going to put 10 in here. I'm not going to put the unit with it. We know that the force is going to be in newtons, so we'll solve that later. The J is going to be the 4 times 5, so that's 20. And the K is 0. There is no K. Then we'll come down here and do the B's. There is no Bx, so that's 0. The By is 3. And then the Z is actually a negative 6. So I'm going to put negative 6. So we have to actually keep that. We always assume that everything is adding. So if you have a minus, it's actually that. So this is what we're going to try to solve. We're trying to solve this 3 by 3 matrix. So here's how we solve it. In the I direction, we're basically going to cover up this particular column. So we're going to cover up the I column, and we're just going to take, I'm going to change colors here just so you can kind of see what I'm doing. So we're going to cover up this column. Here, I'm going to do something. It's going to seem weird, but just bear with me. So we're going to cover up this column right here, and we're going to take this number times this number, so we're going to multiply diagonally and subtract this number times that number. So in the I direction, it's going to be 20 times negative 6 minus 0 times 3. So that's really easy. That's going to end up being negative 120. Technically, this is where I put my units, so I'm going to put newtons on here in the I direction. Okay? So let's move on. I'm going to change colors again so you can kind of see what I'm doing. So now I'm trying to find the J. So I'm going to be covering up this column, and I'm going to take this number times this number. So we're skipping this middle column, and then subtract this number times this number. Now that one's really easy because that's just 0 minus 0. But the other key thing is you always do positive I minus J times that. So it's going to be 10 times a negative 6 minus 0 times 0. Okay, that's easy. So that's going to be, this is going to be negative 60, but we're going to subtract it. So the negative and negative is going to make this plus 60 newtons in the J direction. Okay? And then last but not least, let's throw purple in here. We're going to cover up this column. So we're going to take this number and multiply it by this number and subtract this number multiplied by this number. Okay? So this one is going to be, and we're adding again, so for the K, we're going to take 10 times 3, we're going to subtract 20 times 0. Okay. Now I happen to have zeros in here, so we got a lot of things that kind of canceled. We've had a 0 in the I, we had a 0 in the K, so that kind of affects things. It kind of just keeps everything. There was no common one that would stay there. So 0 times 20 is just 0. We've got 10 times 3, which is 30. So we're going to add 30 newtons in the K direction. And this would be the vector for your magnetic force. Negative 120 newtons in the I direction, positive 60 newtons in the J, and positive 30 newtons in the K. That would be your answer. That's what you would match it up with. I hope this helps so you can take a look. Take care.